Okay, hi guys. We are going to talk about compound inequalities and we're going to add some more notation situations in there. So first, we're going to look at what we will be able to do after this. We're going to be able to solve compound inequalities, graph compound inequalities, and using interval notation to show a solution, right? We've kind of already done that, but now we'll just be using it a little bit more. We will need to know the difference between and or. We will need to know the different ways that compound inequalities can be written. And we will also need to know the meaning of union and intersection. So those two things. And when we talk about union, how it's going like this, and intersection, how it's going like this, et cetera, et cetera. Okay. So compound inequality or combined inequality is two or more inequalities joined together with an or an and. So let's talk about and first. When do we use and? Well, and tells us that the answer must be a solution of both inequalities, right? So in a graph, we would be looking at overlapped regions, right? And if there were no overlap regions, there'd be no solution, right? The symbol that we would use for and is this symbol, okay? And it shows the intersection. Or tells you that your answer can be in either inequalities, okay? And your graph would be any shaded region, okay, that could be included in the solution. And our symbol would be this union symbol right here. Okay, so let's investigate a little bit first through some examples. So solve, then put the solution in the form of a graph and interval notation. So make sure you do both, right? So here's some examples of ands. So if they just simply said this inequality and this inequality. So first thing we would do is we would solve. So here we divide by 2. Remembering if we divide by a negative, we have to change the inequality. We get x is greater than negative 5. And so we can actually use this symbol if we would like. Not union, sorry. I just did this upside down. We can use this intersection symbol. And then we divide by 9 here. And we get x is less than 2. So that intersection means that we're looking for overlap, right? So and means overlap. We're looking for overlap, okay? So if we were looking at this graph, and we had 0 here, and we'll put our best players here, negative 5 and 2, right? 1, 2, 3, 4, 5. We would say we are going to be from negative 5 and greater, and then we would be from 2 and less, and you can see that the green and pink overlap in between. So our graph will be in between. And our interval notation for that would be that we would start at negative 5 and we would go until 2, and we are not including the boundaries because we don't have an equal sign on the inequalities. Okay? All right, you guys can turn off the video and then try the next 2. So welcome back. So we're going to have minus 1, and we're going to have x is greater than 3. And then we're going to add 1, and we have x is less than negative 2, and it's an and, so it's an intersection. So we put our values here. Here's 0, negative 2, and then 1, 2, 3, 3. And so for the first one, x is greater than 3 is going to be from here on over. And x is less than negative 2 would be from here on over. And we don't have any overlap. So no overlap means no solution, because there's no overlap. Okay? Now let's go to the last one. The last one is written differently, right? So this is written the same as saying 5 is less than or equal to 3x minus 4. And is the only one that can be written as a sandwich like this, where 3x minus 4 is in the middle and used twice. We can also write solutions like that. So if we were up on number 1, we could have said that our x was between -5 and 2. So we can take an intersection and write it like that. Okay. But the only one, like I said, that could be written like that is the and. So we will add 4, and we would get 9 is less than or equal to 3x. And so we would have, let's take that down here because I'm really being squishy town right there. And so we will divide by 3, and we get x here and 3. So I like to watch the x's on the left. So you can see that the alligator is eating the x up here, so it's going to eat it down here. So it's just x is greater than or equal to 3, and then so intersection. So we would add 4, and we would get 3x, bringing it down here, is 15, divided by 3, and we're going to get x is less than or equal to 5. So we are going to be looking at 3 and 5. So let's take our numbers. So 0, and then 1, 2, 3, 4, 5. Okay. So the first one says that our x is going to be greater than or equal to 3. So we're going to be filling in that endpoint. And greater than 3 would be going this way. And the other one says less than or equal to 5. So we fill in 5 and we go this way. And so our solution is where the overlap region is, but we are including the 5 and including the 3. So that means 3 and 5 are our endpoints, but we are including them now. So it will look like this. We can also write it like we had done above. We could have said that the x is going to be greater than our 3, but less than our 5. So this is more like interval notation. That one is, so this is interval notation. This is more like set notation, or really close to it. Okay, now let's talk about some ors. So we have or now. So where and meant that we were going to overlap. Or means we're going to take everything. Okay, everything that's shaded. So in our first one, we would add 3, and we would get -2 is less than or equal to x. And then or, which we said we could have the union symbol, right? Subtract 2, 3x is less than or equal to 12. And so if I have 3x is less than or equal to 12, I would divide by 3, and I'd get x is less than or equal to 4. So I would have x is greater than or equal to -2, union with x is less than or equal to 4. So first thing we're going to do is we're going to talk about our end values, which are -2 and 4. 2, 3, 4. And we're going to say that we're going to be greater than or equal to -2. And then we're going to be less than or equal to 4. But we're taking everything, guys. So that means we're going to be taking all the pink, and we're going to be taking all of the orange. So you can see in this situation, our solution is all real numbers. So -infinity to infinity. So we are taking everything, all the pink and all the orange. We're not just taking the overlap because we have the or now, right? We have the union symbol. Okay, you guys can turn off the video, try example 4 and 6, and then come back. Okay, welcome back. So for number 4, we're going to subtract 1, and we get x is greater than 4. Or adding 1, we get x is less than negative 1. So we go to our, also remember we could use a union symbol for the or. So we're going to go to 0, negative 1, 1, 2, 3, 4. Okay. So we are going to be greater than 4, or we can be less than negative 1. Now we're going to be able to take everything. So we are going to take all of the pink, open, and all of the green. So this is our graph, right, for everything, which is what OR is. So how could we write this? Well, we could write this as x is greater than 4 in union with x is less than negative 1. Or we can use interval notation, which is saying we're going to go from negative infinity to negative 1, not including, and then we're going to go in union with from 4 to positive infinity. Okay, so that would be the interval notation. Okay, let's do the next one. We are going to divide by 10. So we are going to have x, and I'm going to write it with the x on the left-hand side, is greater than 1/2. I did not switch the inequality. It's still related to the x in the same way. Or, which means in union, with, we would subtract the 2, and we would get 4x is less than or equal to negative 20. And then we'd have 4x is less than or equal to negative 20, and we divide by 4. So we'd get x is less than or equal to negative 5. We don't have to change the inequality because we did not divide by a negative number. So now we're at 0, and we're going to go to 1/2. So if this is 1, we know where 1/2 would be. And then we're also going to go to negative 5. 1, 2, 3, 4, 5. Okay. So first thing we're going to do is we're going to say x is greater than or equal to 1/2. And then the next one, we're going to say that x is less than or equal to negative 5. And we're going to be able to take all of these things, everything. So we're going to start on this side, going to negative 5. And then from 1/2, go, oops, I didn't mean to do that part. Let's see if I can just erase that, because I don't really want it up there. From right here, I'm taking all of this pink. Okay, so we can write this as x is greater than or equal to 1/2 in union with x is less than or equal to negative 5. We can also write this as from negative infinity to negative 5. Including negative 5, in union with including 1/2 to positive infinity. Okay, so there's our interval notation for that. Okay, hope this helped. Take care, guys.